right, so we can pick up where we ended before the announcement started. So we're back. So we were just saying that we ended up with C was 308. Now we need to do a factor tree and we need to break down 308. So in this space over here, I'm going to break down 308. So 308 is going to go at the top. And then I'm going to do a factor tree. And let me grab another pen, because that one's running a little low. All right, so we're going to do a factor tree for 308. So something times something has to give me 308. And there are multiple things that multiply to give me 308. I'm going to start with 4 and 77. So 4 and 77. If you didn't know that 308 was divisible by 4, it ends in an 8. So you know that it's divisible by 2. So you could have done 308 divided by 2 and then keep breaking it down, keep breaking it down, keep breaking it down. But 308 is divisible by 4 and 77. Now I'm going to break 4 down. That gives me 2 and 2. And now I'm going to break 77 down. That gives me 11 and 7. I'm looking for pairs of the same number. So 2 5s, 2 11s, 2 10s. In this case, I have 2 2s. Pairs go on the outside, leftover prime numbers go on the inside. So when I simplify the square root of 308, it simplifies to 2 square roots. I got 2 prime numbers left, 11 and 7. 11 times 7 is 77. And as a decimal, rounded to the nearest hundredth, I got 17.55. So 17 and 55 hundredths. Okay, and last example we'll take a look at. So let me slide this over. We'll still keep it in the viewing area there so you can see we're doing the same process. We just got different numbers. So we need to start with the base. The base is 4 and 6. We're going to do Pythagorean theorem with 4 and 6. So 4 squared plus 6 squared equals C squared. Calculator, mental math, 4 squared plus 6 squared gives me 52. Take the square root of both sides. And this gives me the square root of 52 equals C. Now, go ahead and keep this. Do not do a factor tree yet because we got to use it again anyway. So go ahead and keep this for when we do Pythagorean theorem the second time. So now we're doing Pythagorean theorem the second time. So that is going to give me, let's write it over right here. So it's going to give me the square root of 52 squared plus 14 squared equals C squared. So I'm using the hypotenuse we just found, substituting that in. And I'm going to take this and use my height from the problem and make it three-dimensional because we're trying to find the length of this dotted line. Now, when you square a square root, this is what I was saying for problem number 2 as far as the 164 goes. When you square a square root, it gives you that number back because they're inverses of each other. So now I have 52 plus 14 squared equals C squared. You absolutely can take this whole thing and type it in decimals, okay? There's no problem with that. You absolutely can take this whole thing, parentheses, square root 52, close parentheses, square, plus 14 squared, type it in decimals, and it'll give you this number that I'm about to give you right now, which is 248. So you absolutely can do this just along the way, just trying to give you some background knowledge along the way. Square both sides, it gives me the square root of 248 equals C. Now I need to do a factor tree for 248. So in this little space over here, I'm going to do a factor tree for 248. So 248. Okay. I know it's divisible by 2, so you can absolutely divide it by 2 and keep breaking it down. But I also know that it's divisible 62 and 4. So 62 times 4 gives me 248. I'm going to do a factor tree, break 62 down. That is 2 and 31. Break 4 down. That is 2 and 2. I'm looking for 2 of the same number. So 2 goes on the outside. Leftover prime numbers go on the inside. So 2 times 31 is 62. And as a decimal, 2 square roots of 62 as a decimal is 52 and 75 hundredths. So let's look at all three of these together. We did the Pythagorean theorem twice for each of these problems. You take your base and do Pythagorean theorem so that you do the two-dimensional regular Pythagorean theorem that we're used to. Then you use your height. So the first example, 7 was the height. Second example, 12 was the height. And then the third example, 14 was the height, because we're looking for the length of this dotted line. Sometimes you do not have to break the number down, like 149 cannot be broken down, but the other numbers could be broken down, which is why they were a little longer than the previous problem.